Assalamualaikum warahmatullahi wabarakatuh. My name is Zihni. Today we are going to discuss about proximate analysis. Okay, what is proximate analysis? Before we look at numbers, a quick refresh. Our results are based on proximate analysis. This is a fundamental method in food science. It's essentially how we break down a sample into its major nutritional components like moisture, ash, protein, fat, and carbohydrates. We need this breakdown because it gives us the essential information required to calculate the product's nutritional value and crucially its energy content, which we then compare to the label.
Assalamualaikum, my name is Syafiah binti Muhammad Rusli. So we move to the objective of this proximate analysis. We have four objectives for this experiment. First is to analyze the basic nutritional composition of the food sample using proximate analysis. Second, to determine the content of major nutrients including moisture, ash, protein, fat, and carbohydrates. Third is to assess the balance of nutrients in the sample and identify its potential dietary value. And lastly, to evaluate the overall nutritional quality and energy contribution of the food product.
So, for the methodology, first we crush the biscuit sample into small pieces for the proximate analysis. Then, we measure the moisture using the oven dry method. For the ash content, we use a furnace to burn the sample. Next, the protein was tested using the cheddar method. And the fat was extracted using the salt-slide extraction method. After that, we calculate the carbohydrate and energy value. Lastly, we compare all the results with the information on the biscuit nutrition label to see if they match. Show the result of proximate analysis. The sample contained 3.03% moisture, 3.55% ash, 27.50% fat, 8.49% protein, and 57.39% carbohydrate. The total is 100%. From the result, we can see that the highest component is carbohydrate, followed by fat, while moisture and ash have the lowest amount. Next, this slide shows a comparison between our experimental result and the value on the food label. The differences are small. For example, our protein is 8.49% close to the label, which is 8.4%. Fat shows a small difference, 27.50% in our test and 29.4% on the label. Carbohydrate and energy value also show only a slight difference. This means our analysis is accurate and reliable. So, for the discussion part, we will look at the moisture and ash content of the biscuit. First, the biscuit had low moisture content, which is 3.03%. This means the biscuit is well baked and dry, which helps it stay crispy and prevent microbial growth. According to study by early 2014, biscuit with low moisture around 1.8 to 2.5% have better texture and longer shelf life. So our result is quite close and show good quality. The ash content is 3.55%, which is considered moderate. This means there are small amount of mineral that come from the flour and other ingredients. Fetas 2015 also found that biscuit ash value usually range between 3.5 to 1.7 gram per 100 gram, depending on the flour type and recipe. So our biscuit may have a bit higher mineral content compared to other.
Okay, alright. Let's move directly to the energy comparisons and see how our lab data stack up against the official label. Okay, first, our experimental lab results, which we got from our proximate analysis, was 508 kilocalories for every 100 grams. We compare this to the number printed on the nutritional value, on the nutritional label, which state 530 kilocalories per 100 grams. The difference between those two numbers turned out to be only about 3.5%. So we got that 3.5% by taking the difference and dividing it by the label number. It's the standard way to check for accuracy. Because the result is so small, just 3.5%, we call this good agreements. It means our lab results and the label are practically identical. Okay, this strongly confirms that our methods using proximate analysis and the attribute factors give us a reliable and accurate estimate of the product's energy. Alright, moving on to the carbohydrates. We found a moderate content of 57.39% in our biscuit sample. This is exactly what we expect, as carbohydrates, mostly starch and sugars, come mainly from the flavor and other base ingredients. Okay, to put this number in perspective, we look at external data. A study by Nurmi et al. In 2015 shows that carbohydrates content in commercial biscuit typically range from about 56.8% up to 66%. Our results at 57.39% sits perfectly within the standard commercial range. This tells us that things like the type of flour and the exact receipt what caused that variation in the industry. Finally, comparing our results to the official production label. The label states 56.6%. Our experimental result is pretty similar, which again shows good consistency with the manufacturer's information.
Next, we move to the discussion of protein. So, the protein content in this biscuit was moderate, 5.87 gram, showing its contribution to both the nutritional value and structural integrity of the product. So, when we compare to the nutritional label, which is 8.4 gram, the value obtained was a bit lower, probably because of some experimental error, such as variation of samples or storage conditions. Nonetheless, both results are consistent with the product containing a moderate level of protein. So, according to Nurmi, commercial biscuit generally contains 6 to 13 gram per 100 gram of protein. So, this support the result obtained in this study. Next, we move to the discussion of fat. So, the biscuit showed an average fat content which is 27.54%. So, this indicates that the product contains a moderate amount of fat, which contributes to its texture, flavor, and energy value. So, when we compare to the nutritional labeling value, which is 29.40 gram, the result obtained was slightly lower, possibly caused by experimental error, which is sample variation or storage conditions. But both stories are close and consistent, suggesting good accuracy in the fat analysis. So, according to the Food and Agriculture Organization, biscuits typically contain 15 to 35% fat. So, this support the findings of this study.
Now, I will talk about the challenges in proximate analysis. First, it is difficult to heat the oven or furnace at a constant temperature. The process also takes a long time because the drying and extraction need more time. Sometimes the lab has limited equipment, like only few lab sets. It's also hard to make sure the sample is mixed evenly. Lastly, the short time during lab make it hard to get consistent results. Next, let's look at the common error. Incomplete fat extraction can make the fat energy value lower. If the moisture is not fully moved, it will affect calculation accuracy. Small mistake can happen when weighing or transferring sample. Human error can also happen during recording or using the wrong formula. Finally, if the instrument is not well calibrated, it may give in inconsistent reading.
Next, we move to the impact of this proximate analysis. So, this proximate analysis identifies the main nutrients in a food sample such as moisture, protein, fat, ash, and carbohydrates. So, it's giving a clear overview of its nutritional composition. It also maintains product consistency. This analysis is essential for quality assurance, ensuring each production batch meets the same standard. So, it helps manufacturers control flavor, texture, and nutritional balance and overall product stability. It also assesses impact of processing. Proximate analysis also evaluates how different processing techniques, drying, heating, or storage alter the nutrient content. This information supports product improvement and process efficiency. That's all from me. Thank you.
Okay, so in conclusions, proximate analysis plays a crucial role in determining the nutritional quality and compositions of food samples. It provides essential information on moisture, ash, protein, fat, and carbohydrates, which helps in understanding the sample's overall value and suitability for consumption or processing. The data obtained from proximate analysis are essential for ensuring product consistency, quality control, and meeting nutritional labeling requirements. Overall, this analysis serves as a key tool in food science and industry for assessing and maintaining the quality and safety of food products.